In this lesson on scientific notation, you're going to learn or review how to convert between scientific notation and decimal notation. We're going to outline the reasons why you would use scientific notation, and you're going to also learn how to use it to simplify some calculations. So before we get into scientific notation, just a quick review of exponents. Remember that 10 to the power of 2 means take two tens and multiply them together. So 10 to the power of 2 is equal to 100. By the same token, 10 to the power of 3 then is equal to 1,000. 10 to the power of 1 is just equal to 10. Anything to the power of 1 is itself. 10 to the power of 0 is equal to 1. Anything to the power of 0 is 1. 10 to the power of negative 1 means 1 over 10, so that's 0.1. And 10 to the power of negative 2 is 0.01. So that's the pattern. The familiar notation that you're used to every day is called decimal notation. Scientific notation is always going to place a decimal right after the first digit. So in order to do that here, we need to take the decimal, which is over there, and move it there. I'm going to write this therefore as 1.2345667, and I'm going to write it multiplied by a power of 10. So I've moved the decimal 6 places, so that's 10 to the power of 6. Some people will talk about when you move it left, make this positive or negative, move it right, make it positive or negative, and remember whether this exponent is positive or negative that way. I actually just remember that this is a big number, this 1 million, etc. is a big number. This 1.2 is a small number, so to make the two things equal, this part has to be big. 10 to the 6 is a big number. So that's how I remember that this is 10 to the positive 6, not 10 to the negative 6. Another example here with a number smaller than 1, I need to move the decimal from there to there. So I already know that it's going to be 10 to the power of some kind of 3. It's 5.63. Now this is a small number compared to this, so to make the two sides equal, it needs to be 10 to the negative 3, not 10 to the positive 3. That's how I remember these. 100 would be 1.0, moving the decimal from there to there takes me through 2 places, and I need to make this bigger to equal 100, so that's times 10 to the positive 2. Here it's again 1.0, but if I move the decimal that way, here this is 10 to the negative 2. 1 is bigger than that number, so I need to multiply it by a smaller number. Okay, pause the video now and do these other 2 for practice, and then you can unpause and check your answer. Okay, assuming you've done that, here are the answers. Let's practice going in the opposite direction as well, starting with scientific notation. So I have 3.06 times 10 to the 4. That means I need to move the decimal place 4 times, and this is a big number, so my number over here needs to be bigger than 3.06. I need to move this 4 times to the right. Okay, pause the video and do these ones now for practice. And here are the answers to those. So once again, the format of scientific notation is a number in 2 parts, one with a decimal after the first digit. If you look up through all of these, you see we always have 1 digit and then a decimal and then the rest of the number, and then multiplied by a power of 10. All right, why bother using scientific notation? Well, first, it makes it much easier to write very big or very small numbers, and we don't have to worry about counting decimal places or zeros. This 6.02 times 10 to the 23 means we move the decimal place 23 to the right. That gives us this. This is clearly a lot easier to read, understand, and write than this, which I had to count very carefully. It also makes the order of magnitude, by which we mean the size, the power of 10, very obvious. So if I wanted to compare these two numbers, all I have to do is compare the powers of 10 to figure out which is the bigger number, because the part over here is always going to be between 1 and 10. So if this 5 is bigger than that 4, that means this is the bigger number. I don't have to even look at the 2.51 or the 9.87. Similarly down here, 10 to the negative 2 is bigger than 10 to the negative 3, and so this is the bigger number than that. Last but not least, it allows us to do certain things quickly and in our head because of exponent rules. Remember your exponent rules when you have 2 numbers with the same base and you multiply them. So for example, 2 to the 3 times 2 to the 5, you add the exponents. So that gives you 2 to the 3 plus 5 is 8. Similarly, if you have 2 things with the same base and you divide them, you subtract the exponents. So 2 to the 7 divided by 2 to the 3 is 2 to the 7 minus 3, or 2 to the 4. Now, when you multiply things, some of which have exponents and are the same base and some of which aren't, you can just multiply the first parts and then multiply the second parts together, by which I mean I multiply 1.2 times 3.0 and get 3.6. And then I multiply 10 to the 7 times 10 to the 8 and get 10 to the 7 plus 8, which is 10 to the 15. Similarly, when I divide, I can divide the non-power part first. So I can divide that part. 4.8 divided by 2.4 is 2.0. And now I divide this using my exponent rules. 10 to the 7 minus 3 is 10 to the 4. When I add or subtract, it's a little bit more complicated because I need to have the same powers of 10. So here I have different powers of 10. Let's just think about this in decimal notation first so we understand what's going on. This is 3,500 and this is 120. So my answer should be 3,620, or in scientific notation, 3.62 times 10 to the 3. That's the answer I should get. But how would I do it if I stayed up here? Well, I want both of these powers to be the same. Let's change this one so that it's 10 to the 3. So I'm going to leave 3.5 times 10 to the 3 as the same number. Now, if I want this to be times 10 to the power of 3, what I've just done here is I've made this number bigger by a power of 10. That means I need to make this number smaller by a power of 10. And to do that, I divide by 10 and I get 0.12. Now that I've got both of these with the same power of 10, they're both thousands. This is 3.5 thousands and this is 0.12 thousands. I can just add them. So I get 3.62. And then the 10 to the 3 stays the same. Okay, so that's scientific notation and how to use it.